just wrote it in the term of dx and dy instead of dy by dx. So in that case, when you see something like this, you just try to rearrange and try to find out which technique that you should use in order to solve for the solution of that problem. So like, if it is coming this way, so you've got to write the equation in the term of dy by dx. Because if you're pretty sure that it's not the first equation, like separable equation, right? It is not separable equation. When you look at it and you see it like this, you know that it can be separable equation. It can be homogeneous equation. So then you got to figure it out whether it is an exact equation. If it is not, can you find the integrating factor in order to make the equation to be exact equation? If so, then you can use that technique. Or you can rearrange it into terms of dy by dx and see like whether it is the linear equation or Bernoulli equation. It's just up to you. Like I said, in one problem, it's not only one technique that you can find a solution. It could be 2 or 3 techniques. It doesn't matter what technique you are using for solving for the solution. But at the end, you would get the same answer. No matter what technique that you use, but at the end, you would get the same answer. Okay? So from this, because I'm pretty sure that it is not separable equation, the way that I'm going to do, I'm going to write it in the term of dy by dx. In that case, I got to divide the whole equation with dx, right? So I would get 2xy dy by dx plus x minus y squared equal to 0. And then I just make the coefficient in front of dy by dx equal to 1, okay, by dividing the whole term, the whole equation with 2xy. And then just make it simple, okay? What do you think it should be? In general, you always, when you write the equation, Bernoulli it look like this, linear look like this. You have the term of dy by dx, and the next term from that is y times any function with x, with respect to x. So if you look at our equation then, you have this term and next should be this term. So this term is supposed to be on the right hand side, right? The third term should be on the right hand side. So it is a what? When you look at the equation like this, what do you think? What kind of technique that you're going to use to solve for the answer? It is a linear equation. Is it a linear equation? No, because you have y there. If it is a linear equation, the whole function on your right hand side is supposed to be as a function of x only. Now it's y, it's not x. So this equation is Bernoulli equation. It's a Bernoulli equation with n is equal to -1 or -1. Then from this, because of course now you know it's a Bernoulli equation. It is the Bernoulli equation with n equal to -1. So from the start, we are going to solve for the answer of this equation by using Bernoulli equation technique. Okay. Then we got to assume v is equal to y to the power 1 minus n, which is equal to y to the power 2. And then you do dy by dx, okay, which is equal to 2y dy by dx. Right? And then first, you want to change dy by dx into the term of dv by dx in your equation. So after you do differentiate of this equation, then you should rearrange the equation in the term of dy by dx is a function of dv by dx. Okay. So I will put this as equation 1 and this 2 and this 3. And then like it's just a pattern, right? The way to solve for the answer is kind of pattern. If you figure it out already what technique that you are going to use, then that's a pattern that you can pick up, right? After you assume d is equal to y to the power 1 minus n, then you do differential of dv by dx. And after that, you just rearrange this term to write down dy by dx as a function of dv by dx. And then you just plug that equation back into your differential equation, which is equation 1, just like that. Then you would get 1 over 2y dv by dx minus 1 over 2xy equal to minus 1 over 2y to the power -1. And then again, make the coefficients of dv by dx equal to 1. You would get dv by dx minus 1 over xy to the power 2 equal to minus 1 as the equation 4. And in equation 2 you have the term of y squared, but now you just change y in term of v already. So just change y squared in terms of v by using the equation 2. So I said that put 2 into 4. We would get dv by dx minus 1 over x times v equal to -1, which is the equation 5. Now our equation 5 is becoming linear differential equation, which has px equal to minus 1 over x and qx equal to minus 1. So now we can find v equal to 1 over the integrating factor times integral of the integrating factor times qx dx plus v. If we know the integrating factor, then we should be able to find v as a function of x. Our integrating factor is equal to exponential of the integrating of px dx, which is equal to integrating of the minus 1 over x dx. So our integrating factor is equal to 1 over x, like that. And then you just plug mu, integrating factor, and qx into the equation 6. Then you should be able to find v. And then after you get b, you just plug the equation 2 back in terms of y. That would be it for this problem. V is equal to x integral 1 over x minus 1 dx plus d. X and then, like I said, plug the equation 2 in there. We know that v is equal to y squared. So the answer would be y squared equal to x times negative ln x plus b.